Alright, gang, this is going to be the third video in the lecture series on the arthropods, and today we want to talk about crustaceans. Now, there's a lot of slides on crustaceans, so I'm going to go pretty fast, and if you need to, of course, because you'll be watching this on YouTube, so you can stop it and pause it and go back all you want. It won't bother me because, it'll be the recording of me and not me. So feel free to do that. Like I said, we've got a lot to cover, so let's go ahead and get started. All right, the crustaceans. So here is the picture of a classic member of the class Crustacea. This is a crab. This is a spiny lobster, which is also a member of the crustacean. And we'll look a little bit at their classifications. This is the phylum Arthropoda, and we are going to be looking at subphylum Crustacea. In that class, there are the following. Here are some of the following major classes of crustaceans. We have Remipedia, Cephalobacardia, Branchiopodia, Maxilliopodia, Ostracoda, and Malacostraca. Okay, so I'm not going to be asking you all of the different classes, but just to give you an idea of some of the ones that are out there. So let's talk about the general features of the crustaceans. They have mandibles. They have moving mouth parts, so they do chew their food. They have biramous appendages, meaning that their appendages terminate into 2 points. They are known to have segmented bodies. Their appendages, their legs are jointed, so they do bend. They have jointed appendages. And their skin, their cuticle, is an exoskeleton. So their skeleton is on the outside of their body. All right? And this is the case for all of the arthropods. There are about 40,000 known species of crustaceans that have been described and classified, and there are probably many, many more. Segmentation in crayfish. Now, we do, if we were there in school, this would be one of our dissections. We do look and examine the body of the crayfish, but we are not going to be able to do that, so we'll have to try to figure out a way to do that virtually. But most apparent is in the crayfish is the abdomen, and less obvious anteriorly due to the fused cephalothorax that is shielded dorsally by the carapace. So the body plan, the main body part, is a cephalothorax, a head and thorax fused together, and it is covered by a very thick plate called the carapace. And then behind that, which is typically what people will eat, is the abdomen. The abdomen is what most people would consider the tail of the crayfish to be. Jointed appendages, they have lots of appendages. So in the crayfish, there are 13 pairs of appendages that are attached to the cephalothorax. 6 pairs of appendages on the abdomen. So if you're counting, we're now up to 19 pairs of appendages. The first 2 pairs of appendages make up the antennae. So they have the large antennae, and then they have a smaller set of antennae called the antennules, and of course they are there for touch and chemoreception, which means they smell. They can pick up chemicals in the water. The 3rd through 8th pair of appendages make up an assortment of mandibles, maxillae, and maxillipeds used in feeding. This is where we would, during the dissection, we would look at all of the different tiny little arms, little appendages that are around the mouth. So the deepest part are the mandibles, and then there's a smaller little set of arms, a little set of appendages in front of those mandibles, and then there'll be 5 total sets of tiny appendages that are all in front of the mouth, all in front of the mandible, and are all used in feeding. The first pair of walking legs are the chilepeds. They have the pinchers and are used to grasp food or used to fend off a predator. The second and third pair of walking legs have the pinchers, but usually they're much smaller, and most of the time on the very last two pair, the fourth and the fifth pair of walking legs, they do not have the pinchers on the ends. They do not show that biramous appendage. The appendages on the abdominal segments, which are segments 14 through 18, are called swimmerets. You would think with that name they would help them swim, but they don't. So why they're called swimmerets, I couldn't tell you, but that's what they're called. And primarily the females will use them to carry their eggs. The males have their first pair of swimmerets are used in mating, and so on this slide you can see the difference. So the swimmerets on the underside of the crayfish body, again, not used in swimming. The females, you can see, this is the female on this side, and here's the male, all right? So the male, the first two pair of swimmerets are used in mating. So the male will use these much larger swimmerets right here. He will use to fertilize the female, and her reproductive opening right there called oviduct there, that's where the male will deposit his sperm into the female. Now you'll notice that the male's other swimmerets are much smaller compared to the females. So when the female lays her eggs, she will use these swimmerets to hold her eggs, and she'll carry them around with her instead of leaving them in a nest or something. Since the male doesn't carry any eggs, you can see his other swimmerets, pairs 3, 4, and 5, are much smaller, and then the first two pair up there than the female. So this is how you tell the difference between male and a female. These swimmerets are much larger on a male, and if they all seem to be the same size as we have in this case, then that is going to be the female. Okay? The 19th and last pair of appendages are the uropods. They are the side of what we would consider to be the crayfish's tail, the two pieces on the little fins on the back, and they combine with the very middle piece at the back of that called the telson. If you remember, this is the same terminology used to describe the tail of the scorpion with its stinger. This makes a large fin, and this is what's used in swimming. So if you've ever seen a crayfish, they will walk forward, but when it comes time to get out of dodge, they flip that tail and then they will retreat backwards, which is a pretty good system. So if defensively speaking, they'll swim backwards, and you may think, well, they can't see where they're going, but they're more concerned with what's chasing them. So this allows them to see what predator is coming after them, and since their pinchers are used in defense, are on the front of their body and they're going backwards, then that means any predator chasing them has to deal with those pinchers. So it's a pretty unique little system of defense. The exoskeleton on the crayfish is tough and light. Again, is made of chitin, which we talked about in the earlier lesson, and it does give the crayfish excellent protection. Problems with the exoskeleton, though, it's hard to grow when your skeleton is on the outside. So what crayfish and crabs and lobsters and all other crustaceans do is they will molt periodically, and when it's time to grow, they'll crawl out of their old rigid exoskeleton. Their new one will be soft and pliable, and that way they can expand their bodies to get that new exoskeleton to fit. And after a couple of days, when it hardens up, they've got a newer, larger, tougher exoskeleton. The downfall is for those 48 hours or so, they're pretty vulnerable because that tough protective exoskeleton, not so tough, it's soft and pliable, and that makes them more vulnerable. It limits their size, so because of that exoskeleton, they can only get so big. To relieve this problem, they replace their cuticle when they outgrow it by molting, which I just explained. Some arthropods molt a fixed number of times, meaning they'll only molt so many times in their lives. Others will molt indefinitely, so just as they keep growing, they just keep molting. The interesting part is if they lose a body part, when they molt, they will grow that body part back. So if a crayfish loses a pincher, no big deal, because when he molts again, or she molts again, she will grow, or he will grow, a new pincher. So sometimes you'll find crayfish with a big pincher and a little bitty pincher, and that means they lost that one, and the small one is growing back in, and that's why it's so small. Their digestion includes a short esophagus linking to a mouth that goes to the stomach, and they have a straight intestine. Ours is curved and is very long. Theirs goes in a straight line, and then that will end in the abdomen at the anus and digestive gland. The interesting part about their stomach is it contains a set of teeth that is called the gastric mill that they will use to grind up their food that they've already sectioned off with their mouth and eaten, to helps grind it up a little further before they pass it on down the digestive tract. So as I was talking about, the stomach is divided into two chambers, the cardiac and the pyloric. The cardiac is used for grinding and storage. Inside the cardiac stomach are the chitinous teeth attached to a muscular lining making up what we call the gastric mill. And that was what I was talking about earlier. So that first section has those teeth called the gastric mill, and it will help grind their food up before they pass it on down the line. After being ground up in the gastric mill, food then passes into the smaller pyloric stomach, which is lined with setae, tiny hairs, that sort particles small enough to pass into the intestine. So there's kind of a lot going on there in their stomach. It's doing a lot of sorting and grinding of the food that they have just eaten. Reproduction. We talked a little bit about the swimmerets that the males use to deposit sperm into the females. They are dioecious, which means they have male and female. They are not hermaphrodites the way the earthworm was. The female can only mate after her final or nuptial molt as an adult. So she is only able to mate after she has that molt. After that, when she molts and that new exoskeleton hardens up, she cannot mate. So she puts off a pheromone when she molts, so the males know that she will be ready, and that's how they are able to reproduce. Why do they go through this? The molting hormone is required for the production of eggs. So the same hormone that allows them to molt will produce the eggs. Copulation is physically impossible unless the female's cuticle is still soft. So as I was talking about earlier, once that exoskeleton hardens up, then they cannot mate. During the nuptial molt, the female exchanges her narrow apron for a broad apron required for copulation and for carrying eggs. And that deals with the underside of her abdomen there. Their growth and development, they have direct development. Which means the young are miniature versions of the adult. They don't go through a metamorphosis the way some other arthropods do. And other egg layers, the eggs are in a larvae called the zoea. It goes through a series of molts to a post-larva called the megalops. So it is kind of a metamorphosis in a way, but most of the time it's microscopic until it develops into the megalops, which will then be developing into the adult. Megalops then molts into a tiny version of the adult, which is what I just said. Balance. They have a unique organ of balance called a statocyst, located in a chamber at the base of each of the first pair of the antenna. Lets them know which way is up. The statocyst is a grain of sand or a small pebble that as soon as they molt, they will grab that, pick up that piece of sand, and it gets into their statocyst, and it will respond to gravity. So there have been studies where they put a crayfish in a totally clean tank with nothing but a few iron filings, and when the crayfish molts, it picks up the iron filing and uses it in its statocyst, and then they put a magnet over top of the crayfish, and the iron filing will then go towards the magnet, making the crayfish think that he's upside down and he flips over. So kind of a cruel way to mess with the crayfish. Okay, that's going to be the end of the section on crustaceans. So we are zipping right through this material. You know what to do. Go to Schoology, find the exit slip for lesson 3, fill out that exit slip, and let me know that you got it. And that'll be all for today. So good job, and we will talk at you later.